Welcome back, boys. This is a continuation of the lesson that you learned last week. Now, last week you learned two things. You learned about a vertical stretch or shrink, which is when the graph would become narrower or wider of the parent function. And then just recently you learned about vertical translations, which would be moving up or down along your y-axis. So you've done each of those separately. So now this part of the lesson is I'm going to put both of them in one problem. Okay, so before we get started, if you just look at the graph here, I already have the parent function for you. So I'm gonna graph this also on your homework so you don't have to worry about graphing it. So the graph that you will have to draw would be this new one, which is our g of x is 4x squared plus 1, okay? So just like before, we're going to have this table of values, and as you can see, these values right here came from me plugging in all of these x values, and there is, as you can see, that's where the red graph came from. So we're going to do the exact same thing with these values, but now we're going to plug them into g of x. So you only have to do half of these because by definition of symmetry, you should know what the other ones would be. So let's do g of -2, and remember PEMDAS would apply here. So we need to do the exponent first. So it looks like you get 16 plus 1, which is 17. Let's do -1. And it looks like you get 4 plus 1, which is 5. Now we can mentally do 0. If we plug in 0, you're going to get 1. And then by definition of symmetry, this would be a 5, and this would be a 17. So now we have 5 new points that we're going to graph. So there are my 5 points. And let's draw our curve. And obviously, just by looking at this, you can see the similarities and the differences between these two graphs. So, same table of values that we just had, same graph. So now we're going to compare it, and we're going to fill in this table. So, I already have the table filled in, but I kind of want to walk you through this. So, the vertex, as you know, we're looking at the new function. So we're looking at the blue one, okay? So here's our vertex. This is our vertex. It's also helpful to label as well. So vertex is 0, 1. So I did that. My axis of symmetry is the dotted line that goes through the center. That's x equals 0. And if you notice, it's the same for both of them. So check. The domain is all real numbers, and pretty much that's going to be true for every parabola that you're going to see in this chapter. Now, the range is something you guys have been struggling with. So the range is your y values. So look at your vertex of 0, -1. Your y is 1, okay? And if you look at your graph, your parabola is opening up. So it's covering all of the positive y values that are bigger than or equal to 1. It is not opening down. So nowhere down here do you see the parabola. So the range would be y is greater than or equal to 1 because it covers every possible positive y value that is bigger than or equal to 1, okay? Because obviously these parabolas are going to go up higher and higher, and they're going to cover all of the big positive numbers. Was there a reflection? No, because they're opening in the same direction. Vertical stretch or shrink? Well, obviously it stretched because it's in the center and it became narrower. And by a factor of what? Well, it's a factor of 4 because your A was 4. And was there a vertical translation up or down? And as you can see, it shifted up, and it was a vertical translation of 1 unit up because the vertex was 1 up from 0, 0. So all you have to do is fill the table in after you would graph the new function. So let's do one more. So let's graph h of x, and it's going to be negative x squared minus 2. So again, there's your parent function. There's my table of values. Notice the red ones are standard for the parent function. So now let's take these and plug them into h of x. Be very careful here. So if we do negative 2, I'm going to put the negative 2 in parentheses, and it's going to be a negative, and if you do negative 2 squared, you get a 4 minus 2. That's a negative 6. And also, a dead giveaway is this negative. You should know exactly how it's going to look. Is it going to look or open up or open down? So that should be a dead giveaway if your graph does not look how it's supposed to look. Let's do negative 1. And we get negative, and then you get a positive 1 minus 2, which would be a negative 3. If we plug in 0, we can mentally do that. You would get a negative 2. Again, by definition of symmetry, these would be the same. So this graph should be opening down because a is a negative 1. So let's plot our points. Oh, look, it does open down. And let's draw our curve. And there you go. So again, there's my table of values. There's my graph. So we need to compare it, and I will explain our table. So your vertex now is down here, which is 0, negative 2. Your axis of symmetry is still the same, and that is x equals 0. Our domain still has not changed. It's still going to be all real numbers. Now your range obviously has changed because your y value is negative 2, and it's covering all numbers that are less than or equal to a negative 2. And was there a reflection? Yes, there was a reflection over the x-axis. That is why it is flipped in the opposite direction. And was there a vertical stretch or shrink? No, because it's the same size technically. Okay, did not become narrower or wider. And was there a vertical translation up or down? Obviously, as you can see from the vertex, it went down 2 units, and there you go. Okay, so hopefully this has been coming easy to you. I'm going to add one more thing to conclude this chapter, but other than that, this is pretty much how you would graph a quadratic function. Okay, so your assignment is on Moodle, and it's a worksheet. And also look at the notes as you do the worksheet. See you next time, boys.